Hello there, this is Dr. Dell, and I want to tell you about what I consider the greatest high school mathematics book ever written. It's titled Precalculus Mathematics in a Nutshell, and it's by Dr. George Simmons. Now, you can purchase a copy of this book for yourself. Just go to Amazon and buy it, and you can actually buy this book for less than $15. And so you can imagine that the main publishers today are not particularly interested in pushing this book because it covers algebra, geometry, and trigonometry, and it is everything you'll need to know as you're soon going to learn, and it's less than $15. Before we discuss the book itself, I want to tell you who Dr. George Simmons is. I met him, if you want to call it that, in the late 1960s and early 1970s when I was teaching an advanced course to seniors and graduate students at a couple of different universities on the subject of topology and modern analysis. Now, this subject is foundational to all modern theoretical mathematics, topology, and then modern analysis is one of the applications of that subject. And this was a book that Dr. Simmons wrote and published in 1963, and it's one of the finest books in this field that I've ever seen, even to this very date. In fact, if I were going to be teaching this class, even today, this is the book that I would use. And indeed, if you read even the introductions to this book, even if you're not interested in the contents, then you would be very impressed with Dr. Simmons' abilities as a teacher. I consider him probably the best mathematics teacher that I've ever run across. And this is the book that I taught out of. I taught the entire book. It was a one-year course. And the first semester, a little more than a semester, was about topology. And then we went into a variety of important subjects in analysis. And in fact, these are the subjects that underlie many of our modern scientific theories like quantum theory. And this is a fantastic book. And that's how I met Dr. Simmons. Now, he subsequently wrote a book on differential equations, and then another one on calculus, and then finally, in 1986, he published this book, and I was amazed when I heard about it and read it, and I vowed that if I ever had an opportunity again to teach high school mathematics, this would most definitely be the book that I would use, and I'm going to be telling you about it in this book. Okay, let's start talking about this book. As you can see, it was published originally in 1987. And you can start out by reading the preface, which is very interesting. Remember, this book covers algebra, geometry, and trigonometry, and it does it in only 119 pages. And Dr. Simmons makes the comment that most college mathematics teachers would be overjoyed and astounded if their students came to them from high school in full command of this much background material. But most high school graduates do not even come close. Now, I'm here to verify that. I've taught for many years. I taught calculus, differential equations, and modern math at various schools in this country, and rarely did I have a student that knew as much mathematics as was covered in this book. There are actually three chapters, one on geometry, and then one on algebra, and then one on trigonometry. And as I said, the whole book's about 119 pages long. Now, I'm going to tell you a little bit about each one of these as we go, and then I'm going to tell you how I use this book or would use it today in teaching your student on how I would recommend that you might want to use it. First of all, this is not really a self-study book. I don't think any book is a self-study book for most students. I think that they need to be guided through this with a teacher. They need to be encouraged to do the exercises, and they need to be given frequent feedback in the form of quizzes on it, which of course is what I do when I use it in my online training programs I'll be telling you about in just a moment. Now, as I said, it covers algebra, geometry, and trigonometry. He starts it with geometry, and he talks about triangles, circles, cylinders, cones, and spheres, and then he has several appendices. Now, this book, you ought to read his introductions to these subjects. One of the things he talks about in here is that there's a problem today that tends to kill students' interest in geometry long before they reach the meat of the subject. And the root of the problem is what Dr. Simmons calls slavish adherence to the doctrine of deductive reasoning. This is the notion that knowledge is somehow not legitimate or genuine until it has been organized into an elaborate formal system of theorems that are carefully deduced from a small number of self-evident truths or axioms. Now, he says, and I agree with this, deductive reasoning is a very interesting idea that educated people ought to know something about, just as they ought to know something about a lot of other things like internal combustion engines and so forth. And in fact, this was very popular with philosophers and scientists in the 17th century and since then, and was applied by them to all kinds of subjects like physics and so on. But geometry has continued to be strangled by this outmoded philosophical doctrine down to this present day, even though science kind of shook off its grip 200 years ago. Now, what he's talking about is the way geometry is sometimes taught today in the standard curriculum, and that is an emphasis on proving theorems in a very formal way, and this can really take the life out of geometry. It slows things way down. It's very difficult for a lot of students to follow, and so it's not the proper way to teach it. Now, having said that, you definitely want to employ a logical reasoning and deductive reasoning when it's appropriate to explain things, but as you'll see when you read this book, and you should definitely if you're a teacher at all or interested in high school math, you should get this book and just read it at the very minimum. And you'll see that he goes through and discusses important topics, and he gives reasons for them. He gives what you would call proofs, but they are not done in a very stylistic and formalistic way. And so he goes through and discusses the important things that you need to know in geometry if you're going to go on into further topics in mathematics. And it's all very interesting. Now, I will point out something he does that is absolutely remarkable. He derives, if you want to say proves, the formulas for the volume and the surface area of a sphere, which I have rarely seen done in high school geometry books. He does it using something called Cavalari's principle, and it is just a fantastic way of proving this. And in fact, I don't even cover this in the first pass through this book, which we do in what I call Tier 3. I don't discuss that until we get into Tier 4, and even then, it's not required for the people that aren't possibly going to go into mathematics itself. He also then in appendices has several formulas that are very interesting. You perhaps have never heard of, let's see if I can get onto the appendices. These are the problems. He has lots and lots of problems, which of course is very important in mathematics, as you know from other things that I've been discussing with you. And let's see if I can find it. And he has something called Siva's theorem, which is a very interesting thing that a lot of high schools don't even cover. And then he has some formulas that are quite interesting. Brahmagupta's formula, and there was also then one called Hane's formula that I think I skipped by earlier. And I talk about these in some of the videos on my website, which you can go and read and learn about. So that is his treatment of geometry. Then he goes and he does algebra. Now, algebra is a very interesting subject, and it's a tool that needs to be learned and used throughout mathematics, but you don't want to, you want to make it as practical and get as you can, and you don't want to belabor it any more than you have to. And this is what he does then in his section on algebra. There's very little that I would want a student to know about algebra that is not covered in his chapter on algebra. And then finally, he goes to trigonometry, and he covers trigonometry in a very, again, quite adequate way for going on into calculus, for example. So this is the book that I would use and recommend, and I'm going to tell you in a moment now how I do use it in our 10-tier program. Well, now, first of all, those of you that know me and have studied my materials, my website, know that I do not use any textbook, including Dr. Simmons' book, as the very first pass-through mathematics for post-elementary students. In what I call the foundation course, or the practical math foundation course, I cover the topics of algebra, geometry, and trigonometry with some preliminary materials without any specific book that's been written. I use my own notes because I want to present this material in a way that I think is appropriate for a beginner, for the first time they're going to be exposed to these things. Now, these are the subjects that I cover in the foundation course. And remember, this whole course is self-paced and interactive and takes most students only about 50 hours to complete everything. So it's about a 3-month program for most students. The very first thing I do, as you know, is I teach them to use a calculator, which is what I call the power tool of mathematics. And the one I use is the Texas Instruments 30XA, which I consider to be a very useful and practical calculator. It's the one I use when I'm out in industry doing work. And it only costs about $10, and yet it has everything on it that you want for practical math. So it's a tool you use. And indeed, it's the way you do mathematics, and therefore it's the way you ought to be learning mathematics. Then I have a section on pre-algebra, then algebra, then geometry, and then trigonometry. And I call the first two chapters, if you want to call it that, Tier 1, and then I call this Tier 2, Algebra, Geometry, and Trig, the first pass through. And this is prior to using Dr. Simmons' book. Now, just to give you an example, the calculator course, by the way, only takes a student usually about a week to go through, maybe a week and a half. It's a lot of fun. It's almost like a game. And then here's what I cover in pre-algebra. And basically, I'm wanting to be sure that the students understand arithmetic, all the rules of arithmetic and how numbers are put together. So we talk about all the rules of addition and multiplication and the distributive law and fractions and ratios and things. And we talk about squares and square roots and reciprocals and exponents. And this is what I consider basically pre-algebra. And then what this is kind of amazes a lot of people that don't know that much about math, or maybe they do know quite a bit about it and are indoctrinated to the standard curriculum. And here's what I cover in algebra. And there's basically only 8 lessons in algebra. And then I put in a couple more. Now, it looks like it's trig, but it really isn't. It's just doing the type of manipulations you do in algebra, because I teach you how you solve equations and the rule of algebra, and then we solve the basic equations you run into in industry over and over and over. And these are the basic linear equations, and then very special cases of the quadratic equation and the equation where you have like the square root of x equals a. And then I also show them, if you know that the sine of an angle is a, then how do you find the angle, or vice versa. And we teach them that without even teaching them what trigonometry is. This is something you can do with a calculator. It's sort of an algebraic type manipulation. I call these near linear algebra. These are very easy things to do. And this is algebra. And it doesn't take a student very long to go through, and it builds their confidence, and it gives them the tools they need then as they go on. And then, as you know, we continue on, and in geometry, we cover basically the things that you need to know in geometry. I talk a lot about geometry. I give a preliminary discussion of it, and that's called the introduction. Each one of these lessons, by the way, as you know, is a video and then a set of problems and then a quiz, an online quiz, because they need to have the feedback. If you studied our methodology of teaching mathematics, you'll understand what that is. And then these are the topics that I cover in the first pass through geometry. And we talk about the basic things that you'll run into in industry. Triangles, different types of triangles, how to use similar triangles. By the way, G6 may be the most important chapter in this. Similar triangles are used over and over and over in solving problems in industry. It's more important, much more important than proving triangles are congruent. That's where you get into the deductive reasoning type thing that Simmons talks about, and we don't even discuss it in the foundation. Of course, different types of polygons, and then how to do areas. And then we talk about circles, of course, the different aspects of circles. And then we get into three-dimensional figures. We talk about surface areas and volumes of blocks and cylinders and cones and spheres and so on. And then I talk about when geometry is not enough to solve certain problems with triangles, because that is what you need trigonometry for. And then we cover trigonometry in a section here. Let me find the table of contents. And then here's what we discuss in the foundation course about trigonometry. It's simply the basic trig functions and how to use them to solve any kind of a triangle problem you'll ever run into. And in fact, as you probably know from the other materials, the classic example I like to give is the triangle, the triangle whose three sides measure 3 inches, 4 inches, and 6 inches, and calculate the area. And quite frankly, that's a hard problem to do, and it's the last thing we teach them how to do using what we call the generalized Pythagorean theorem. Now, this is the foundation course, and this is what you need if you're going to go into industry in a non-professional technical career. And as I said, it takes about 50 hours to go through. And then I want to tell you what I do with Dr. Simmons' book if we go beyond the foundation into the upper tiers of mathematics. So I'll talk about that in just a second. Okay, now I would like to tell you just how I use the Precalculus Mathematics in a Nutshell book in the training that we do in our 10-tier program. We actually use this book now in Tier 3. Remember, the student now will have been through the first 2 tiers, which is our Practical Math Foundation course, and they'll already have been introduced to algebra and geometry and trigonometry at a practical level. And now these are students that are probably going to go beyond the practical level. They want to be scientists or engineers, or as you'll see in a moment, maybe they just want to do good on the SAT test. And so this is how I use the book. I divide Dr. Simmons' book into 50 lessons, it turns out. And this is what I call Tier 3, and these are the lessons, and these are the pages in Dr. Simmons' book that I use for each lesson. Each lesson consists of a video, and then a problem assignment out of Dr. Simmons' book. Once in a while I have to supplement it with additional problems if I choose to. And then a quiz, an online quiz, to verify that they've mastered that section. Now, you might notice that I don't start with the algebra. I actually start with, I don't start with the geometry at the beginning of the book. I start with the algebra. The first lesson I give is actually on page 34. It's the real number system, and then we go there. And there's pedagogical reasons that I do it that way, and if you're going to teach out of Dr. Simmons' book, you might want to follow this syllabus or this lesson plan, as it were. You can download it, a PDF off of our website, and see exactly the order in which I do things. And then you can follow and see all of the different things that are being covered. And it's a very, very thorough book. There's very few things that I want a student to know about algebra or geometry or trig that are not included in this book. Now, there are a few things. For example, I give a few additional notes on ellipses, do a little bit more than he does, and I cover hyperbolas. These are conic sections, and I don't know why he doesn't cover those in his book. I also do a few other things with notes that to supplement what he does in his book. But by and large, this is what I cover in Tier 3. Now, I must tell you, there are things that in his book I leave out of Tier 3 that I consider a little too deep for that first pass through, and I cover them in Tier 4. So I use the same, more or less, lesson plan in Tier 4, except now I go through these things a lot faster because now they're review. Many of these things now the student's seeing for the second or third time. And then I add a few more in-depth topics, such as I told you earlier in the video, Cavalari's principle to prove the formulas for the surface area and the volume of a sphere. Just use that as a couple of examples. Now, you also know that we have a course for SAT success that we teach. And I use Dr. Simmons' book for part of that. In that course, this is the syllabus for that course. We start off, and this is aimed really at students that may not want to go into a STEM career. They may not want to pursue science or engineering or technology, but they want to do well on the SAT. These could be English majors or people that want to go into social science or something where they don't really have that much use for math, but they want to do well on the SAT. And this is designed to help them do that. Well, we start off and use certain things out of the Practical Math Foundation course. Not everything, by the way, because you don't need trig for the SAT, so I leave that out. Then I have special topics that I cover that are particularly aimed to help people with certain SAT problems. You'll see over here, these are SAT problems off of one of the College Board's SAT sample tests. And then I use 16 lessons out of Dr. Simmons' book, and that's in the SAT program. As a matter of fact, just to see a contrast there, this is the Tier 3 lesson plan, and the ones that are in bold and numbered over here are the ones that we actually use in the SAT success program. So you can see there's a lot of material in Dr. Simmons' book that you do not need to know for the SAT. And this, by the way, is sort of the genesis of a lot of students' problems. They're in the standard curriculum, all of this material and more is covered. and they can get bogged down and confused and lost, and then they don't get the things they really need to do well on the SAT. So that's the key to success on that. You always want to know the goal of your student and why you're teaching them a particular topic. And in the case of the SAT success, it's so they can do well on the SAT. Whether they're ever going to use that again in their life doesn't really matter. They're just trying to score high on the SAT. Now, clearly, students that are going to be go into science and engineering and are taking Tier 3 are going to get all of that and a lot more, and so they're going to naturally do quite well on the SAT. And so that's what I wanted to tell you about Dr. Simmons' book. I can't recommend it enough. If you are a math teacher or even a student and you want to know more about these subjects, this will be the best $15 you'll ever spend, and I think you'll find it very enjoyable, very enlightening. And of course, if you need help in understanding, you need someone to help you, then I naturally invite you to participate in our 10-tier system and so forth and so on. And indeed, I hope you have joined our crusade, our Math Literacy Crusade, and are going to try to help any students in your sphere of influence to get an optimal, appropriate math education for them, because we believe that is one of the ingredients of having a optimal, fulfilling career and life. This is Dr. Dell signing off, and I will see you on another video. Bye-bye.